afternoon. I've spent most of my day prepping those other two videos. This is the third video, the one that is to accompany the motor control project. So you'll notice I don't have the timer or the relay on the board because, well, we're not using them. We're going to use the motor starters and we're going to hook them up. So, going back to our whole imagination usage thing, it becomes a little bit different, right? Because now we're going to treat the lights as something other than lights. We're going to treat them as motors. Okay? We're going to treat the green light as reverse. Actually, I'm going to switch them. We're going to do two scenarios. So we are going to use the green light for our forward button and the red light for our reverse button. But those buttons are going to become different things depending on which scenario we're going to do. So the first scenario, and this video should be a lot shorter than the other one because I really only need to just hook it up and show you various things. Okay, like I said in the first video, we have our two leads for our coil. Alright, if we wanted to turn just this red light on, we could apply 120 volts between the two coils and it would do what we needed it to do. But I don't need to demonstrate that because you saw that in the last video. So we're going to grab some leads out here and we're going to start building. You notice I have nothing hooked up here because this is the motor control scenario. So what I am going to do is I'm going to start to build my neutrals. And what we're going to do is we're just going to control this one motor with the forward button just to start off. So I've got my neutral in and now I'm going to start building my circuit coming in the input of the stop button, and this should be very familiar from the last video. Okay, and then I'm going to switch over to red for my switch leg. Going to bring this switch leg all the way over and tie it to the coil. Okay, nothing new here, right? So I'm going to turn it on and we're going to see it come on again. So hit the forward button, light comes on. But just like the previous video, we don't have a memory circuit. So on a motor starter, how do you create the memory circuit? On the relay, we just looped power back around. What do we have on a motor starter that we can use to loop power back around? And the answer to that question is we have our auxiliary contacts on the side. This one that's on the top of the motor starter is a normally open auxiliary contact that will change state when the motor engages, when we put power to it. This bottom one is normally closed. We'll get to that when we get to the forward and reverse scenario. Also, just as a side note, this starter has additional normally open contacts, and you can't see them because of the angle, but they're back here. And that's what makes this like a motor starter block, because it's got a few things that a normal contactor wouldn't have. Okay, so just so that you can see, we're going to use the normally open contact on this side, and we're going to build a memory circuit. So the first thing we need is we need to power one side of the memory circuit with a power source that will be broken by the stop button, just like in our previous scenario. And then, again, my yellow lead, I come off of the other side of the normally open contact and loop that back to, yep, you guessed it, the power side, not the neutral side, but the power side of my coil, however I've done it. And in the previous video I said that there were certain things that didn't matter, and in this case what I meant is that you could totally put the hots over here and the neutral over there, or vice versa, and it doesn't work, which is to say the coils are non-polarized, they're non-directional. So I'm going to leave it like this, turn it on, show you that we do in fact have a memory circuit because the light stays on. And then one thing that helps people understand this concept of memory circuit is if I reach over, and I say don't do this at home, but if I remove the memory circuit loop, that breaks the whole chain. Now I've replaced it and it works. Okay, so memory circuit on a motor starter. Now you know, piece of cake. On the relay, we were using the same contact that we were feeding power to what we were controlling. On a motor starter, we're simply using a normally open contact, and that's it. Alright, so let's get this all back. I don't know if you can hear or notice, but I have been shutting off my power strip as I do this. So safety first. I don't want to get shocked any more than anybody else. But now we're going to get to our first motor control scenario. Now hopefully you guys watch the video because I'm going to make an announcement. I changed the nature of the motor control assignment so that all you were doing was controlling 2 motor starters. And there were a few control scenarios you could use to do that. One of them was the sump pump scenario, and the other one was the forward reverse scenario. Now if you do the sump pump scenario, it's actually just a little easier, but you have to let me know. In fact, you have to let me know which scenario you're doing, or I won't know. I will have to guess at which one you're doing right. Okay, we controlled this one with a different switch than I wanted to. So I'm going to make some adjustments because we're going to make this one, we're going to make all these line up to what we're controlling. So these 2 wire loops, no, that's not live. I was just kidding. These 2 wire loops are actually going to control this side, and these 2 wire loops are going to control this side. Okay, so just to back up, I've built my neutral circuits out so that I have a pathway back to the neutral from here to here to here. So hopefully you can see how that all becomes 1 wire. We would use the same number, right, on our diagram. And by the way, you don't have to do the numbers and stuff on your diagram. And then I've moved my my switching over to what I've labeled the reverse button. Okay, and now I am going to extend this out. Now I've already run out of black wire leads, so I'm going to switch over to green. Now I am going to extend this power, so the input of the reverse switch over to the input of the forward switch, and what that does essentially is it just makes all of these the same, right? So I have power to both of these out inputs as long as my stop switch is not pushed in. So now I can start building my switch. I need a longer one. Building my switch loop for the second motor starter. Okay. Same thing applies. I'm just going to control both of these starters the same way, but with 2 different buttons. And I'm going to build my memory circuit exactly the same way, looping around. Now we have one of our control scenarios. One of the ones that would be acceptable for your assignment. Hopefully you can recognize which one it is. So I'm going to move over. And I'm going to put power to the board. And I'm going to say, imagination. This is a float. This is a float. And this is a float. This float is set to come on at 5 feet. This float is set to come on at 2 feet. And this float is set to come on at 10 feet. So our water is filling up in our sump pump well. Okay? And we get to 2 feet, which means this is going to be closed, which we have to imagine it's automatically closing. It's filling up fast and we get to 5 feet. Okay, we're at 5 feet. Sump pump is running. It's not running fast enough. Water continues to fill up. And we finally hit 10. And our second pump kicks in. Right? Now it's doing awesome. There's no water flowing through. Right? But we have memory circuits in place. So as soon as it completely drains and we get below 2 feet, we hit the stop button. And there you go. So run that again. This is the start float set at 5 feet. This is the emergency float set at 10 feet. And this is the stop float that's set at 2 feet. So we get to 5 feet and our pump comes on. If it continues to fill up and gets to 10, both pumps kick in. And then once it drains the sump pump well down to 2 feet and below, it shuts off. So, looky there. Draw it. Alright. I have to make a decision. Do I want to unhook all of this so you can see it all get hooked up again? Yes, I do. Second scenario. I'm going to leave the neutrals intact. And I am going to unhook all of this. Except for my power on my terminal blocks, because that's not going to change. I'm still going to have 2 inputs, but we're going to do the forward, reverse, start, and stop. So this will be forward, and this will be reverse. I left all my neutrals intact. All of my power scheme is the way that it should be. Okay, and now I've got to hook these up. Now the one thing that I'm sure a lot of you are going to forget on your motor control drawing or on the gen file is your interlocks. Okay, so that's honestly, the interlocks are the only thing that's different between the sump pump scenario and this scenario. So let us begin. All right, we need to interlock or lock out this motor starter if this motor starter is engaged, and vice versa. So how do we do that? Well, we simply run the switch leg through the normally closed contacts. Then we use the normally open for a memory circuit. So I want to go in order, so let's start with the reverse. We're going to take our reverse button and we're going to run it through the normally closed contacts and then bring it in to energize our coil. So what will happen is if this is energized, this normally closed contact will open and prevent power from getting over here. Then we're going to do the same thing. With our forward button, we're going to come off of the output. Boy, these things are... And we're going to come through our normally closed contact that is on our reverse. And then we're going to do that. Okay, so without our memory circuits in place, this would still work, but you have to hold the buttons down. So I'd have to hold the forward button down and test whether the reverse button worked. So we still need to get our control circuits in place. And for that we need to provide power, to one of the sides of our normally open contact. It seems to work out well for me to keep that associated with the switch. But I want to show you that you can actually just take that power off of any wire loop that's going to be broke or opened when you push the stop button down. So this is the output to the stop button. So that'll work. And then again, I've run out of black, so now I have green. And I can do the same thing. Can plug that into here and feed it, or I can plug it in over here, because that's still the same line, right? But we'll plug it in over there. We'll feed it. And now we're just 2 wires shy of completing our forward, reverse, start, stop with interlock scenario. Just like that. Okay. And let's go play with it. Alright, forward. Our forward motor is running. And if I hit the reverse button, I can't turn it on. If I hit the stop button, though, everything resets. I hit the reverse button, the red light comes on. I hit the forward button, the reverse light doesn't come on. So there you have it. Forward, reverse, start, stop with interlocks. And we would call these magnetic interlocks because we're using the coil to change the state of the auxiliary contacts. A mechanical interlock would be a physical connection between the switches themselves. So again, if I have the forward motor running, the reverse is locked out. If I have the reverse going, the forward's locked out. And then just to tell you how important that is, remember that when we reverse a motor, all we're going to do is change leads, right? We're just going to flip leads, but we're going to power the same motor. So if they ever were to close at the same time, you would create a direct short, and that's no bueno, right? So forward, lockout, stop, reverse, stop, lockout, and there you go. Now the one thing we didn't really talk about all that much before I go and leave you to the rest of this semester is our overload contacts. So what the heaters do, or the overload protection does, is they monitor the current flow. And if the current flow in amperage gets too high, then it will allow this area to open. Okay? When it opens, we're cutting power to the coils. And so it's commonly the first thing that your neutral goes through. And you'll get this in your 3rd and 4th year because this is actually a part of the state test. But you will bring your neutral into the overload and then take your neutral out to the coil, so that if it overheats, if the motor gets overdrawn, it'll shut the power to the coil off. Now these are just tied through, so I can't really demonstrate. But anyway, thanks for spending this day with me, and hopefully you enjoyed hearing my voice and my videos, and we will we'll see you at the conference that we're going to have this Tuesday, and hopefully we can get everybody passed and through their test and waiting until they can come into the lab, like I said, about a week or 2 weeks before the next semester starts. We're going to schedule some time for you guys to come in and try to hook these up by yourself. But just remember, this is just an introduction, so no pressure. But this is, like I said, we're just trying to get you familiar with this stuff so that you become more and more comfortable with it and are successful at passing the state test. So thank you guys.